The human brain is a marvel of nature. It's an intricate network of billions of neurons. These neurons communicate with each other. This communication allows us to think, learn, and create. Understanding how our brains learn can unlock new levels of knowledge acquisition. We can use this knowledge to design systems that learn similarly. This is where deep learning comes in. Deep learning uses artificial neural networks, which are computational models designed to simulate the way our brains process information. These networks are inspired by the intricate and complex neural networks in our brains, which consist of billions of interconnected neurons. These artificial neural networks consist of layers of interconnected nodes or artificial neurons that process and transmit information. Each node in the network is like a tiny brain cell, receiving input, processing it, and passing it on to the next layer. These nodes are organized into layers, with each layer transforming the input data in some way. The first layer might detect simple patterns, while deeper layers recognize more complex features. By adjusting the connections or weights between nodes, these networks can learn from data. This process is known as training, where the network is exposed to vast amounts of data and adjusts its weights to minimize errors. This learning process mirrors how our brains adapt and acquire new information. Just as our brains strengthen certain neural pathways through repetition and experience, artificial neural networks adjust their connections to improve performance. Imagine a child learning to ride a bike. At first, they stumble and fall, but with each attempt, their brain adjusts the connections between neurons, improving their balance and coordination. Similarly, deep learning models learn from their mistakes. When a model makes an error, it adjusts its weights to reduce the likelihood of making the same mistake again. Over time, with enough practice and data, these models become more accurate and efficient. They can recognize patterns, make predictions, and even generate new content. Just as a child becomes more confident and skilled at riding a bike, deep learning models improve their performance with each iteration. This iterative learning process is what makes deep learning so powerful. It allows machines to learn from their mistakes and continuously improve over time. As a result, deep learning has become a cornerstone of modern artificial intelligence, enabling advancements in fields ranging from image recognition to natural language processing. In today's digital age, we are bombarded with information. The internet, social media, and other technologies constantly vie for our attention. This constant influx of information can be overwhelming for our brains. Our cognitive abilities are limited. We can only process a certain amount of information at once. This overload makes it challenging to focus on a single task. It also hinders our ability to retain information effectively. We often find ourselves forgetting what we just read or learned. This is where deep learning techniques can be incredibly beneficial. They can help us manage this information overload and learn more effectively. Our brains, while remarkable, have limitations. One major challenge is our limited working memory capacity. We can only hold a small amount of information in mind at once. This makes it difficult to process complex concepts or learn new things quickly. Distractions further exacerbate the problem. Our always connected world is full of notifications, social media updates, and other distractions. These diversions disrupt our focus and make it harder to concentrate on learning. Overcoming these challenges is crucial for effective knowledge acquisition. Section 5. Spaced repetition, the art of reviewing. One powerful deep learning technique is spaced repetition. This technique leverages the science of memory. Our brains tend to forget information over time. Spaced repetition combats this by strategically timing review sessions. By reviewing material at increasing intervals, we interrupt the forgetting process and strengthen our memories. Imagine you're learning a new language. Instead of cramming vocabulary words, you review them at spaced intervals. You might revisit them a few times on the first day, then again a few days later, and so on. This spaced repetition helps solidify the words in your long-term memory. Section 6. Active recall. Testing your memory's mettle. Another effective deep learning technique is active recall. This method involves actively retrieving information from memory instead of passively rereading it. By forcing our brains to work to recall information, we strengthen the neural connections associated with that information. Think of it like exercising a muscle. The more you use it, the stronger it becomes. Similarly, the more you practice recalling information, the better you become at retrieving it from memory. This technique is particularly helpful for remembering facts, figures, and concepts. Section 7. Chunking and interleaving, breaking down walls of information. When faced with large amounts of information, our brains can feel overwhelmed. This is where chunking comes in. Chunking involves breaking down complex information into smaller, more manageable pieces. This makes it easier for our brains to process and remember the information. Interleaving complements chunking by mixing up different subjects or topics during study sessions. Instead of focusing on one subject at a time, we switch between different subjects. This interleaving helps our brains make connections between different concepts and improves our overall understanding. Section 8. A personal transformation conquering code with deep learning. I experienced the power of these deep learning techniques firsthand while learning a new programming language. It was a journey filled with challenges and breakthroughs, moments of frustration, and exhilarating successes. Initially, I struggled to grasp the syntax and concepts. The new language seemed like an insurmountable mountain, with its own set of rules and intricacies that were foreign to me. However, I decided to incorporate spaced repetition, active recall, and chunking into my study routine. These techniques, often used in deep learning, became my allies in this learning journey. The results were transformative. Spaced repetition helped me remember the syntax by revisiting the material at increasing intervals, ensuring that the information stayed fresh in my mind. Active recall forced me to retrieve code from memory, solidifying my understanding. By actively engaging with the material, I was able to reinforce my learning and identify gaps in my knowledge. Chunking allowed me to break down complex programs into smaller, more manageable modules. This approach made it easier to tackle each part of the program one step at a time without feeling overwhelmed. By consistently applying these techniques, I was able to learn the language faster and more effectively than I thought possible. Each small victory built my confidence, and soon, the once daunting language became a tool I could wield with ease. This personal transformation was not just about mastering a programming language. It was about discovering the power of deep learning techniques and how they can be applied to conquer any challenge one step at a time. Section 9. Unlock your potential. Embrace deep learning for knowledge. Deep learning techniques offer a powerful approach to enhancing knowledge acquisition. These methods are not just about memorizing facts, but about truly understanding and retaining information in a meaningful way. By understanding how our brains learn and by applying techniques like spaced repetition, we can ensure that the information we learn stays with us for the long term. Spaced repetition involves reviewing information at increasing intervals, which helps to reinforce memory. Active recall, another powerful technique, involves actively stimulating memory during the learning process. Instead of passively reading or listening, you actively engage with the material by testing yourself. Techniques like chunking, where information is broken down into smaller, manageable pieces, and interleaving, which involves mixing different topics or subjects during study sessions, can also significantly enhance learning. By incorporating these methods, we can overcome cognitive limitations and unlock our learning potential. Imagine being able to learn new languages, master complex subjects, or acquire new skills more efficiently. These techniques can help us learn faster, remember more, and make deeper connections between different pieces of information. This interconnected understanding allows us to apply knowledge in various contexts, making our learning more versatile and practical. I encourage you to explore these techniques and discover how they can transform your own learning journey. Share your experiences, experiment with different approaches, and find what works best for you. Everyone's learning style is unique, and what works for one person might not work for another. Continue to seek out new ways to optimize your study routine. Whether it's through digital tools, study groups, or personal reflection, there are countless ways to enhance your learning process. The pursuit of knowledge is a lifelong endeavor, and it's important to stay curious and motivated. Embrace the challenges and enjoy the journey of learning. With the help of deep learning techniques, we can all become more effective and efficient learners. These methods not only improve our ability to retain information, but also enhance our critical thinking and problem-solving skills. So, take the time to invest in your learning. Explore different techniques, stay consistent, and most importantly, enjoy the process. Learning is not just about the destination, but also about the journey. We can all become more effective and efficient learners. Embrace deep learning techniques and unlock your full potential.